This video is going to give you an introduction to confidence intervals. Consider this scenario. Researchers are interested in determining the average cost of tuition for a single semester at a 4-year university in America. They take a random sample of 40 students and find that the sample mean is $11,425. Assume that the population standard deviation is $3,500. The population in this scenario consists of all college students at a 4-year university. What we want is the average tuition cost for a semester for all of these students in the population. The problem with this is that we can't reach all of these students. There are just too many of them for us to go out and collect information from all of them. So our solution is to take a sample of some of these students and find out how much they pay in tuition. Now, X bar is what we call a point estimator of mu. It's a single value that estimates a population parameter. What this means is that 11,425 is our best guess for the average tuition cost. However, there's natural variability within a population. The sample mean is almost never equal to the exact value of the population mean. So, point estimates don't actually provide much value without taking into consideration the variability of the estimate. The solution to this is to use a confidence interval. What a confidence interval is going to do is it's going to give us a range of reasonable values for the true population mean instead of just a single point. More formally, a confidence interval is an estimate of a population parameter that uses an interval of reasonable values instead of just a single point. Now, in order to construct this confidence interval, we also have to define the margin of error. The margin of error is the maximum amount that we would expect the sample mean to differ from the population mean by. All of our confidence intervals that we create are going to take on a similar form. They're going to start with the sample statistic, and then we're going to add and subtract the margin of error from the sample statistic. The margin of error is going to be some multiplier times the standard error of the statistic. A confidence level refers to how confident we are that the interval that we create contains the true value of the parameter. Generally, what we do is we choose 90, 95, 98, or 99% confidence. These percentages represent the probability that the confidence interval that we generate contains the true value of the population parameter. Going back to our example, what we want to do is calculate a 95% confidence interval for the true population mean cost for a semester of tuition. What this means is that we want to find an interval where we're 95% confident that the interval we construct contains the true value of the population mean. Here, 95% is our confidence level. We need 3 things to be able to do this. We need the sample mean, we need the standard error for the sample mean, and we need the multipliers. These multipliers are going to be z-scores that yield 95% of the area between them. Taking a look at the statement of the problem, we already know that the sample mean, x bar, is 11,425. The standard error for the sample mean, denoted sigma sub x bar, is calculated by taking the standard deviation of the original distribution and dividing by the square root of the sample size. This gives us 3,500 divided by the square root of 40, which is 553.4. The multipliers are a little bit more involved to calculate. What we want to do is find the number of standard deviations away from the sample mean, x bar, in each direction so that we have the middle 95% on the standard normal distribution. Since we want the middle 95%, what this means is that we're leaving out a total of 5% of the area in the tails. If we're leaving out a total of 5% of the area in the tails, this means we're leaving out 2.5% of the area in each tail because the standard normal distribution is symmetric. If we're leaving out 2.5% of the area in each tail, this means we need the 2.5 percentile and the 97.5 percentile. To picture what's actually going on with a confidence interval, here's the standard normal distribution. It's centered at 0, and what we want are the two z-scores such that the area between the upper and the lower z-scores is equal to 0.95. This also means that we're leaving out 2.5% of the area in each tail. So what we need to solve for are these two z-scores, the 2.5 percentile and the 97.5 percentile. The way we can figure out what these percentiles are is to refer to the standard normal table. Since the standard normal distribution is symmetric and the two values we want are opposite each other, all we really need to do is identify one of the percentiles and then take its negative to get the other multiplier. Here's 0.025 in the standard normal table. This is the 2.5 percentile. Working our way out to the left and up to the top tells us that the z-score that corresponds to 2.5% of the area in the lower tail is negative 1.96. Because we have symmetry, the z-score that corresponds to 2.5% of the area in the upper tail must be positive 1.96. In order to construct our 95% confidence interval, the multipliers for the margin of error are going to be plus or minus 1.96. At this point, we can go back and bring the sample mean back into the equation. Our confidence interval is going to be centered at x bar. We know the multipliers and we know the standard error. So the confidence interval is going to extend 1.96 standard errors in each direction from the sample mean. What this means is that our 95% confidence interval for the population mean is going to be x bar plus or minus 1.96 times sigma over the square root of n. In interval form, the lower bound is going to be x bar minus 1.96 times sigma over the square root of n, and the upper bound is going to be x bar plus 1.96 times sigma over the square root of n. At this point, we can now construct the entire interval to estimate the average cost of tuition for a single semester. We'll start with the lower bound. The lower bound is going to be x bar minus 1.96 times sigma over the square root of n. X bar was 11,425 minus 1.96 times sigma 3,500 divided by the square root of n, the square root of 40. Working out this calculation, we get a lower bound of 10,340.34. The upper bound is calculated in a similar way. Instead, we have x bar plus 1.96 times sigma over the square root of n. Everything in this equation stays exactly the same, except the minus sign now becomes a plus sign, so the upper bound is 12,509.66. Putting everything together, our 95% confidence interval for the population mean cost for a single semester of tuition is 10,340.34 to 12,509.66.